So everybody, let's do this. Going with the elementary flow. Now, I didn't go over the notes of this in class, but I figured it would make more sense if I just did it in MATLAB and made it a lot more interesting for all of you. But like I was saying, that Laplace's equations, which we've learned that our stream function and our velocity potential both satisfy Laplace's equations. Laplace's equations already have known solutions, which means there's known little functions I can use for my stream function or my velocity potential that come straight from those, so I satisfy those equations. So this lets us plot things. Like, for example, this right here is the stream function for a source, and it satisfies Laplace's equations. So what does it say? Well, right here on the top, it's simply saying, what is the strength of my source? That's that symbol right there. Then I have 2 pi, and I have my angle in radians. So I'm going around, and what this tells me then is that my stream function is going to change in value as I go around the circle. And I don't like only having I feel like I should have more lines here. Let's see here. Make sure I do this right. Contour 20. I put the 20 on the end. I can't remember where I put the 20, so.
What assignment is this?
This is programming assignment 4 in our class. Run.
You said the top numbers, well, the top symbol said.
That's the strength of the source. So you can imagine this in various different ways. It's just think about like a little black hole that's shooting out stuff in all directions, because we are two-dimensional. And hopefully it will run all my things. I'm believing. Run section. There it is. It showed up. Don't really know why it's in such. Okay, there we go. It ran. It took me a second. So you can think about this since stream functions are two-dimensional, not three-dimensional. Velocity potential is three-dimensional. Stream function, and you can say this is just a point, and I have flow coming out of that point and just shooting out in all directions. You can also think about this, you're trying to do it like in 2 dimensions. Like if you had a flat plate, 2 panes of glass, and I were to have a tube coming straight towards me into that flat plate and then shooting liquid in between the 2 panes of glass, it would shoot out between the 2 panes in all directions. So that's what a source looks like. Now our stream function is simply a value. So each of these lines right here has a different value, and it's a constant value along those lines because our stream lines are those lines. A line that has a constant stream function value is a streamline. That's how we find it. So each of these lines has a constant value, and therefore those are all streamlines. So this is our first one. It's a source. If the strength is negative, it turns into a sink and all the flow goes into it just like a little black hole. That is one of our solutions to Laplace's equations. Now, we have other types of elementary flows as well. This one right here is simply a uniform flow elementary flow. So uniform flow is simply saying that I am just the wind that's blowing my face. All the wind is going in the same direction at the same time. So if I wanted to actually show that to you, I could do this. Here, I'm going to rerun this section, and you'll see just a uniform flow. I forgot to put a, okay, there it is. One more time with a semicolon. That is not it.
It's supposed to be just like straight lines.
It is. And it should come out, it's deciding not to do it. Let's see. It's because I forgot to put the side uniform in here. That's on me. I clicked the wrong one. It did what it was supposed to, everybody. I programmed it wrong there. There. So you see how there's a bunch of straight lines? So if I have wind just blowing straight forward, that's a uniform flow. And so my streamlines are simply a bunch of horizontal straight lines. So each of these lines with a different color has a constant stream function value. And since it has a constant stream function value, I will have that's a stream line. This is the value of the stream function, and it's given by the strength of my speed of my wind times the distance from some point, and then finally sine of the angle. Now, if I want to, I can add these together. So if I wish, I can add this uniform flow, which you see right here, and I can put a source in the way. So think about it this way. If you have a wind blowing in your face and you blow into the wind, what happens? It will kind of dissipate. You're going to cancel each other out, right? So let's see what happens then. There it is. So you can see right here that suddenly my uniform flow, it's having to bow around something, right? That's because my source is canceling it out right there. This is what's called a semi-infinite body, because it's the same exact thing that would happen if I had a rod with a rounded tip that I stuck into a flow that was infinitely long, because the end never affects anything. We're just saying that that never actually affects anything later on. It can also just be very long compared to the size of the tip, and that's still going to count. This also brings us into an interesting point. If I wanted to, I could figure out where my stagnation point is right here. I can find that stagnation point. My stagnation point is simply where the velocity goes to 0, and I could use these plots to figure that out. And it would be all based on the strength of the source versus the strength of my free stream velocity. See, for each of these elementary flows, you're going to have one parameter that you get to, a little knob you get to turn. So for the first one, it was the strength of the source, this guy. For the second one, it's the speed of my velocity. And as I change one or the other, I'll begin to have very different cases. So like for this one, let's make it a very, very, very strong flow. You see I made it 250? It's now 10 times stronger. So that uniform flow is now 10 times stronger than it was before. Let's run it again. Do you see how this guy has gotten much smaller? Like you can still see it barely there, right? But that uniform flow is dominating now. Now if I make it weaker, you can see my source begins to dominate more and more.
It's like a more powerful leaf blower blowing.
Yeah, leaf blower blowing into the wind and blocking it, or whatever it is. So in one case, I'm the leaf blower. In the other case, the leaf blower is blowing at me. Like in one.
Say like instead of you just blowing to the wind, like a powerful leaf blower is the wind, basically.
Yeah, that would be the other case. For this case right here, the leaf blower is what's blowing into the wind. It's trying to block it out. You're more powerful in blocking it out. And so when you do that, you cancel out more of the wind, and so you have a bigger area that you're affecting. Okay, and let me change that back. How? I worked really hard. This is called a live document. Live script, man. I like it a lot better. It's a lot nicer when you're doing these kinds of things.